The division part of complex number. We are now to explain the logical part of it and the way you can be able to solve it easily. If you are given questions like this, that to divide 5 minus 2i by 4 plus 3i, it's very simple. When you rewrite, you said 5 minus 2i all over 4 plus 3i. The exact thing that is equivalent to in the part of the topic that we're able to solve, it is just that you rationalize. You reach a rationalization method to say 5 minus 2i all over 4 plus 3i. In case you are to multiply this, you now change the sign to be minus. I was able to say that 4 minus 3i. That is just the only method to use to divide in a complex number. Therefore, it will now be 5 to multiply 4 minus 3i to minus 2i bracket 4 minus 3i all over onto 4 bracket 4 minus 3i plus 3i onto 4 minus 3i. So therefore we have, this is 20 minus 15i minus 8i. This is minus times minus. We have plus 6i squared all over 4 times 4 making 16 minus 12i plus 12i. This is minus 9i squared. For to proceed, you discover that this is I square. It will give you, I've explained the other from another video, that I square will give you minus 1. Will give you minus 1. It will give you minus 6. So it will now be 20 minus 6. 20 minus 6 minus 15i minus 8i minus 15i minus 8i all over. You'll be able to see that 12i will cancel 12i. This will give you minus 1. So minus 1 times 9, it will give you plus 9. So it will be 16 plus 9. It will give you 16 plus 9. So by the time you add together, we have 14 minus 23i all over 9 all over 25. So you're able to split, just say 14 over 25 minus 23 over 25 i. That is the first example. Let's solve the second. Let's just go to the third. Well, we call it second here, which says that express 1 all over 3 plus 4i in real and imaginary. If you have to solve this, as I've explained early, it means 1 over 3 plus 4i will be solved by rationalization, which is 1 over 3 plus 4i multiplied by 3 minus 4i over 3 minus 4i. In expanding, this will be 3 minus 4i all over 3 times 3, we have 9. 3 times 4, we have minus 12i. This one plus 12i. So this one will give you I times I will be minus 1 already. 4 times 4, this will give you minus 16. So it will be plus 16. So the final answer will be 3 minus 4i all over. This will cancel this. It will be 25. So if this one give you 25, we now have 3 over 25 minus 4i over 25. That is the final answer. So we able to solve. Let's solve the next example, which he said we call it third here. He said simplified 1 plus root 3i all over 2 plus root 3i. So if you are to solve this, it will now give you 1 plus root 3i all over 2 plus root 3i will be equal to 1 plus root 3i. So you have to rationalize to be 2 minus root 3i all over 2 plus root 3i to multiply 2 minus root 3i. So in the process of expansion, 1 will multiply all through to be 2 minus root 3i. Root 3i will multiply, this will give you plus 2 root 3i. By the time this one will multiply this, to give you root 3i times root 3i, to give you minus 3i squared, because the root will cancel the root. So we now have, since the conjugate, you just have to just say that 2 times 2 onto minus 2 root 3i plus 2 root 3i. This will give you minus 3i squared. Therefore, we have, this will be 2, this is 1, this is 2. It will end up giving you 1 plus root 3i, because this is 1, this one is 2 of 3 root 3i. So this one will now give you, this is 3i squared. I squared is minus 1 to give you plus 3. If you're able to check this one will cancel this. This one will give you 4. This is I squared will give you plus 3, which is equal to 5 plus root 3i over 7. So if you are to write the final answer, it will be 5 over 7 plus root 3i over 7. That is how we solve division part of a complex variable. Thanks for the class.